Yo, what's up, party people? Well, if you don't know who I am, my name is Dr. James Utley. I am your resident code breaker data scraper. And I'm here today. Well, actually, we're going to explore this ESM Metagenomic Atlas from Meta, I guess, or Biohub, or Meta, or whatever it is. So I've been predicting. So I have a project that's called Bolter, which is for another time, but it is a protein prediction structure engine written in Rust. It was my final project for how to grow almost anything, but the ecosystem has gotten bigger. So it's got a builder, which is basically generates a YAML file. Then it's got Bolter, which is Rust implementation of Bolt's 2 model, and pretty dope in my mind. Then I have built a viewer, which is more consistent with an AlphaFold viewer. So it has the viewer and it also has the PAE model confidence. But that is not why we're here today. We are here to explore this amazing protein structure prediction atlas. This is like one of three things that Meta has, or Biohub has put out. The first one is the ESMC, which I forget. I got to check it out myself. And then there's the ESM Fold 2, which is like the Alpha Fold 2 thing, Alpha Fold thing, basically prediction engine. And then the last one is this Atlas, which I'm most excited about because how is this going to help me? This is going to help me because I'm going to use this. I'm going to benchmark Bolter performance off this, right? Okay, but anyway, without further ado, let's get into it. Let's get into it. Okay, so first off, we're going to look at this open source atlas of 772 million predicted metagenomic protein structures. That is a ton. Blow my mind, which is great because that means there is more data to train for Bolter. So we're all living in harmony here. I know some people have messaged me about not living in harmony, which is not true. I'm living in harmony with all those that are working in protein prediction. That is true. All right, so let's explore this thing, which is actually amazing. Okay, so first off, we get this amazing orb, the orb of proteins. And this orb is pretty amazing here because it's like, at first made no sense to me. But then I started looking at it and I was like, oh wow, this is legit. It shows all these different protein structures here on the right top, and you're cruising through. And then it says exploring the 1 million out of 772 million proteins, and then it has this color coding, which is like for confidence. But anyway, we're gonna zoom in, whoa, extreme close up, and we're gonna let it catch up. So we're going in more extreme, and if you see, we get down here to each little dot, which is actually amazing. And we get to this little like cross the plane into this little protein layout where it says all the proteins that are all laid out there. All right, but anyway, let's pick at this one. This one looks like a little complex one. Okay, so it's got some regions that are not so confident. And okay, so first it gives you this one. So you select this, you got all the overview. Ooh, this one here. This is what I really care about is the PLDDT. And this one is like 90%, which is crazy. That's really amazing. Let's go ahead and switch another one to see if we can find. Okay, so we got some 80s. What I'm like looking for is the ones that are trending down where they're not so confident, and we'll get there. We'll find some. So like this one's high 90s. All right, well, so let's go ahead and review the structure. So it's going to pop open this. Let's see if you guys are viewing it. Yes, you are. Great. And then you're going to see all these different regions. Okay, and it's going to highlight the region. It's going to tell you the score. Like this one here is low, like on this color right here for model confidence. So something like this. All right, so, and it uses this molecular viewer or the mole viewer, the most common one. I mostly use PyMole, but this is also very common, like browser-based guy. So yeah, it's all there. All right. So now, for example, is it gives you all the data, and if we zoom out, it's pretty amazing. So this is just the first look. I'm not trying to make this a tutorial because you'll probably get one of, and then we're here like the multiverse. We're not alone. But anyway, I'm not trying to make this like a tutorial, but I'm going to be doing a lot of, oh, what's this weird little dot right here? Go ahead and zoom in. This little weird little anomaly. You see that little anomaly there? It's like Google Earth here. We're going to get through and find out what that is. A little exploration. Okay. So it must be this guy. Why is it there? Huh. Not sure. Let's check out the structure. But you see, this atlas is ridiculous. Well, oh, it was actually the one that we were highlighting. So it was, Not that crazy. Okay, anyway, this is the ESM Metagenomic Atlas. All right, so how does it work for me? Well, it works for me because I see this as ESM getting bigger. We're just doing more, no more area, more proteins are being folded. But if you think about it this way, it's like as you're getting deeper, meaning like more specificity, I'm not sure. I think we're still going to run into all the same problems that we're used to, which is weird in terms of prediction. We have these weird regions that are probably not so confident. So there's always a way to exist for everyone. Like, and so how does this work? So I take this is all open source, all the data is open, and I just stress test Volter in a design of study, and this is now my benchmark. So I was going to benchmark off of some AlphaFold stuff, but this right here is super user friendly, meaning like this atlas is super user friendly. Like I could select some random proteins. Then after that, I can just straight up throw the sequences in, predict, see, matchy, and be great science. Anyway, with all that, we'll see you next